This is October 20th, and we are working on the test cell of the porous concrete. Curtis Hinman is drying out the area where we will do some of the testing. Curtis, why are you drying that out?
Well, this is an ancient ritual done on pervious concrete. And heat it up, make it. No, I'm just kidding.
Oh, okay.
No, I'm just trying to dry off the area so that we can glue this cylinder down. And so the idea is to get this. We got to put some plumber's putty around the inside of this cylinder and get it relatively watertight, and then we'll add our water and time how fast it goes down.
Oh, okay. So the water's actually going to go into this green contraption.
Yep.
Actually, and then we're going to.
So we want to try to stick it down temporarily with the plumber's putty. Get it watertight enough.
And your expectations are that it will drain at a certain rate?
Well, we'll have to see. I mean, it's pervious concrete, you know, newly installed. Typically, it's not unusual for it to drain at 500, 700, 800,000, 1,200 inches per hour. So I would assume this is going to be somewhere in that ballpark.
It's kind of a lot better than the soil, isn't it?
Yeah, it's oh yeah.
I mean, our soil
is. Unless you have soil that's just, you know, rock and sand or rock.
Well, weren't our infiltration rates pretty slow here?
Very slow. Oh yeah, our soil infiltration rates are far lower than what this concrete is.
Mm-hmm.
Yeah. So anyway, just try to get this stuff, get this plumber's putty stuck in here as best as possible. And it's not totally watertight, but hopefully we can get it enough that it will, you know, most all the water will just drain down into the concrete, not out the sides of this.
Sure.
So this gives you a good relative infiltration rate. It's not super accurate, but I use this for comparing over time, so we can do it next year and the year after, and the year after that, and we'll watch how it changes over time, and for that kind of test, this is fine.
So this may sound like a really dumb question, but you have the concrete, which is going to have a really good infiltration rate, going down and hitting eventually the soil.
Yeah, we won't experience that today.
No, I know,
the amount of water we're gonna.
So does it block up because our soil is so poor, and yet this concrete is going to drain really well?
Yes, probably over the. If this concrete is taken care of over time, you know, this should stay. The infiltration rates in the concrete here will probably always be more than our underlying soils. But remember, we have a big, deep bed of base aggregate.
Right, we've seen that in some of the pictures.
That provides a lot of storage.
Yeah.
So
yeah,
it's at least my prediction right now is that we're going to have to see some really, really huge rains to ever see any water coming out of the system.
Well, we'll let you finish up right now, okay?
Out of here?
Yeah.
Where?
We had to pump that dang pond out.
Oh, out of the pond. Huh.
It came. I got photos. I got a video of it on Saturday.
Wild. But coming out of the under drains in this?
Oh yeah.
Huh.
It was running like a son of a gun.
Really? No
Yeah.
kidding. Not the upper drain. The lower. Did you unplug the lower drain?
Yeah.
All right.
But I don't think you're going to see any infiltration problems.
No, not on this.
We'll check back with you a little bit later.
That